This is the Sprint 6 review for Team GVR-Bot. Our team consists of Cadet Tan, Bansky, Moffitt, Vosberg, and Uhara. Our instructor is Major Larkin, and our advisor is Lieutenant Colonel Lawrence.
We have just completed Sprint 6, our final sprint for this project. During Sprint 6, the major feature additions included the prediction model, and the major events included the Sprint 6 review, the prototype demonstration, and project stay.
Our Sprint 6 goal was to develop code for the algorithm and conduct the final validation experiments to test the prediction model accuracy and complete the continuity file and documentation. Our challenges were the maintenance of the GVR-Bot and testing equipment, and troubleshooting the algorithm code. Our sprint backlog. For this sprint, we had a capacity of 178 hours, and we completed 251 hours.
This is our burn down chart for Sprint 6. As you can see, we had a large spike of hours before Project Day on May 3rd and completed the rest of the hours before Sprint 6 review. 251 hours demonstrates the increased number of hours we had to put in to complete our project on time. While 179 hours were required, we completed the necessary hours to finish the project.
Here is a breakdown of our individual tasks. The colors reflect the component of our sprint goal that was completed by each cadet. Key points to note are that Cadet Bansky and Cadet Moffitt worked on data formatting for the algorithm and continuity documentation. Cadet Tan worked on implementation to Mission Command UI as well as supplemental tests for validation. And Cadets Uhara and Vosberg coded the algorithm and checked the algorithm for accuracy.
This is our high-level algorithm. We have a state of charge as determined by the voltage, a state of charge determined by the current, and a state of charge levied from the SM bus. We used weighted averages to develop our algorithm. This is the SM bus state of charge. As you can see, some tests end at 0 with reporting 0, while tests have erroneous readings, do not reach 0, or are at 0 for an extended period of time. For this, we have to use other measures to determine our state of charge. One measure is the voltage. This is a graph of our voltage per state of charge. The black line is the average of this. This is a capacity ratio per state of charge used to determine the current state of charge. All the tests start at different points as per battery, but end at 0.
Here are the algorithms we use from scikit-learn. They include a random forest classifier, support vector machines, regression and classifier, and 2 linear models, ridge and regression. Here's the average error for our algorithms for each 10% interval of the state of charge. We used this data to determine which algorithm we will use in our final algorithm.
This is our final algorithm. As you can see, we use both primary and secondary algorithms over each 10% increment of the battery. This allows us to choose if we're using current or voltage, along with each of the 5 algorithms, to decrease the overall error of our predictor. By using each algorithm individually in different parts of the battery, we created an adaptive algorithm that changes over time and produces the average overall error of 4.39%, which is tested on over 1.5 million lines of data.
Here is the 2-minute video we have prepared for Project Day.
This is a demonstration of Mission Commander UI. Once the icon is clicked, the GUI will be brought to the screen. This can be used to show the documents as well as run the robot in real time. Once the robot is running, a user can select the battery drop-down from the file menu to show the current battery information in the terminal. In the terminal, you can see the different variables pulled from the battery using the bubble test platform and the battery percent remaining using the algorithm at that time. The user can also scroll over the battery drop-down and select the battery graph to view the battery graph over time.
This is a reflection for Sprint 6. Our lessons learned during the sprint is we underestimated time required for developing machine learning code and constraints on user interface due to threading. Moving forward, we have our continuity products for GVR-Bot on the SharePoint, share drive, the GitHub, and our hard drive. This concludes our Sprint 6 presentation. Is there any questions?